Data Science with Buck Woody.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company empowering .NET teams to be self-sufficient. And they are hiring architects as well as .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for that. And finally, be sure to check out the new video show, Architect Tips. My guest today is a gentleman named Buck Woody, and Buck is an applied data scientist working on the Azure Data Services team at Microsoft, and he uses data and technology to solve business and science problems. With over 39 years of professional and practical experience in computer technology, he's also a popular speaker at conferences around the world. He's an author of over 700 articles, 9 books on databases, machine learning, R, and he also sits on various data science boards at 2 U.S. universities and specializes in advanced data analysis techniques. He is passionate about mentoring and growing the next generation of data professionals. Buck, when do you sleep? 700 articles. Wow.
Well, I think sleep is for people that haven't found coffee yet, right?
Awesome. Well, welcome to the show. We're glad to have you. And there's probably people who've seen you speak at conferences and read your articles, but for those not familiar with you or your work, give us a little quick overview of your background and kind of any significant things that led you to what you're doing today.
Yeah, it's kind of interesting. I have a lot of friends, and you probably do too, and their kids, right, are now graduating high school, and they come to you and they go, "Oh, Jeffrey, you know a lot about that tech stuff, and my son, he's really good with video games. He should go get into computers, right? What should he do? What should he do?" And you're like, "Oh no, here we go," right? Just because they can play a video game. But I've always told people, and I've always believed this myself in my career, that you'll always have a job if you work with data or security or both. I've seen hardware sort of come and go. I've seen development sort of come and go onshore, offshore, all over the world. Lots of people can do it. Low barrier to entry for those things. Not that they aren't difficult to do or you can't get employed. It's just that those things are more accessible to a lot of people. But data is the central part of anything, isn't it? On my University of Washington profile, when I taught there, I had all computing is just rearranging data. And if you think about that, even a game, you're just rearranging the data. You're making a pixel blue or you have red or yellow or whatever it happens to be. So to me, it was the central place I could get and keep a job. I grew up kind of poor, and my biggest thing was job security, right? So I wanted to find a place, and I loved, like most everybody, when I, my age, because I was around when the original Star Trek came out. I used to watch it religiously as a young guy. And I just was fascinated by Mr. Spock, and science and data and computers and all that. Live
long and prosper.
Yeah. And at the time, computers were, only mainframes. You didn't have one in your home or anything like that. That would be outrageous. So I wanted to get into a job where I worked with computers, and I felt the quickest way to do that was sort of data and security. And I've went in the military for a while and got out, and I ended up working for IBM for a little bit at an IBM store, actually. And then off to NASA for a little while down at Cape Canaveral in Florida, where I live. And then I took a couple of roles in healthcare and consulting, IT. And I've been a manager. I've been a developer. I've been just a little bit of everything, but always around data. And then I was working in a large company here in Florida, and Microsoft approached about 16 years ago and said, "Hey, you want to come on board?" And so I did. And I was part of the SQL Server team for many years. And then we had this thing called Red Dog that came out. little program called Red Dog, and that became Microsoft Azure. And so I joined the Red Dog team and was part of some of the early parts of Azure. And that was really exciting. And when it came out of what we call incubation, which is sort of our startup culture, and became a product we sold around the world, I left that and went to Department of Defense, still with Microsoft, doing consulting. And I was an architect, and I like to say I was doing things for people, because that's what I'm allowed to talk about, things for people.
Sure.
And when I got done with that, the whole machine learning and AI and stuff became real. And since I had dabbled in AI in the 70s and had statistics and so on in my background from college, I jumped back into that role, and I've been sort of in the machine learning and AI portion of Microsoft ever since.
Well, let me ask you about that, because I think so many people just assume that AI is a new thing. And okay, I need to learn this new thing. You just said, "Oh yeah, I was doing it in the 70s."
Yeah, yeah.
What was the nature of it in the 70s?
Yeah, it's kind of interesting. I actually started way before that. There was a symposium held, and I think it was 1948 or 54. I've forgotten the actual date, where the statement was made: human behavior can be quantified into patterns at such a level that soon machines will be able to do it. And so it was believed with a lot of hubris that we are so predictable as humans that basically we're just a bunch of patterns. And so computers are patterns. So why couldn't there be a thinking machine? And we remember the Turing test and all those sorts of things. So the ideas of artificial intelligence go way back into just basically statistics, predictive analytics. And some of the statistics we do, I do a show with a young lady here at Microsoft. Her name is Anna Hoffman. She's just a wondrous, amazingly smart person. And it's called Something Old, Something New. And we did this thing where she would go over an AI construct, and I would show the math behind it, like where that really came from in the 1800s or whatever. And so artificial intelligence in the 70s became a series of things. There was, do you remember expert systems, Jeffrey? Do you remember that?
I do. And that was right around, I think, decision support systems was also a common term in there.
Yeah. And an expert support system was, I would come in and say, okay, Jeffrey, you're a surgeon. What do you do? And you say, well, if they, I have them lift their arm, and if they lift their arm and it hurts this way, I work on this nerve. And I would write that down. I'd say to the computer, have them lift their arm. Does this nerve hurt? If it does, then operate on their arm. And that was called an expert system. You took an expert and you simply transferred as much as you could to the computer. And that's sort of like taking a paper form and putting it in Excel and calling that, automation. It's really not, is it? It's just doing it a different way. But we did have some things like fuzzy logic, like, well, when they lift their arm, if it's slightly painful, it gets a number like this. If it's more painful, it gets a number like that. And if it gets this higher number, then you do something else. So you had some fuzzy logic and some heuristics. A lot of the maths around that sort of thing started coming out to where you could get more and more predictive. And languages like Prolog, do you remember Prolog by any chance?
I've never personally used it, but I remember it.
Yeah. So that was, those kind of things were around. We were dancing around this. And then it sort of went dormant because it got overpromised, which, by the way, it still does. Whenever I talk to companies, I find there's sort of you've seen this so many times, I'm sure, where people, the CEO sits there and we need some AI. And I'm thinking, you want like a large box of AI or a small box, a venti or
a case of it,
a case. And so they have two forms of this. One is the magic thinking of, they think it's Jarvis from, Marvel movies or something, and that it's just human, but smarter. And then the other side is all that's just not true. It's just a joke. That's not real. And the truth lies somewhere in the middle, probably closer to the it's not true side, but it lies somewhere in the middle. Our phones now, we can talk to them and they can change that into words. We take for granted some of the technologies that really are artificial intelligence. So along came after that, it sort of went dormant because it was overpromised. And after that, sort of this idea of data mining came around. And data mining is just predictive analytics, but over larger sets of data. You were able to do things like classification algorithms or clustering algorithms, where we say people that like this book also like this book. And it's real simple to describe. A clustering algorithm is simply getting a bunch of people in the room, and I come up to Jeffrey and I say, put everybody in here into 3 groups and make those groups as similar as possible. So you would immediately start saying, okay, let me give everybody by weight first, and then by height, and then by age, and then, okay, no, those 3 don't work. I don't have enough people that are the same age. Let me get this. You would start looking for these features. They're basically just attributes. And you would say, you've told me 3 groups, so I'm going to center everybody around that. Now I come in and I go, okay, good. Now I can pick from one group, and I know those people are similar and will buy my stuff.
Yeah.
Like if I can sell to this person, this other person will also buy because they're in the same group. And you're like, well, if you put them into 4 groups, that might be more, you might have more efficacy with that. And I go, oh, okay, we'll divide them up into 4 groups for me. And so these kind of algorithms are just part of data mining. These have been around for a while. And then we had some real breakthroughs. We had some very big breakthroughs on sort of the maths around scaled data, not a few hundred or a few thousand data points, but millions. And I guess I have to do this when I'm holding my pinky to my mouth. Yeah. Or trillions of data points, right? That the human, you just can't do that, but a machine can. And then you got to scale that sort of out. Like, how do you scale that out? You can't scale it up because of the speed of light. At some point, it can't deal with that much. So how do I scale that out? So those technologies came around. Now, those are the newer ones. And so those allow things like deep learning and so on to come into play, which are much more complicated to sort of describe.
Okay. That's a good overview. And now, shift gears into from that to data science, which is the buzzword today. And of course, some people think, okay, it's this new thing that I have to learn. Again, it's a new thing. But let's attempt to not talk about so many buzzwords. And because I think so many developers out there, they work with data, but maybe they're doing reporting, or they throw around the term business intelligence, but it's all just, oh yeah, somebody needs a report. So what are the building blocks of data science? Just attempting to get back to fundamentals.
Yeah, that's a great question. And I think it was Socrates who said, the beginning of wisdom is the definition of terms. And I think that's probably where we should sort of start. So if we think of the whole world around data, what does that mean? There's collecting data, there's doing something to data, there's transforming it, and so on. So that world of doing something with it is sort of data analytics. So if you think of a big umbrella, it's data analysis. And you do this all the time. You look up and you see the traffic light is red. You've evaluated some data. Your irises took it in. Your rods and cones turned it to edges and turned it into colors. Your brain went to a memory section and said, that means I'm supposed to stop the car. Your foot pushes on the brake or whatever, right? So in that case, you've actually done data analysis to drive.
Okay.
And that's all data analysis really is evaluating some input. And then the other part of data analysis is acting on the analysis, because you can do the analysis and not do anything about it, right? So I tend to liken this to a bank. If you think about a bank, I can bring money into a bank, just like you can put data into a system. And whether that's a relational database system or whether it's NoSQL, doesn't matter. You're storing data somewhere. And so the bank is storing that. And then I keep giving them my money over and over and over. And then at some point, I want to see how much money do I have. So I go to the ATM or I go to the teller or I go online and I say, how much money do I have? That's a query. And I still do that every day. And so do you. You look at your balance. Yeah, that's just a query. So have queries gone away? Is data science the new thing? No, of course not. You still have queries. You will always have queries. And so the number one thing a developer needs to understand is, how do I do transactions, putting data in, putting money in the bank, taking money out? And interestingly enough, I can do other things at a bank that are still just mechanical, such as I'd like to get that dollars and put them into euro. The bank can do that for me. They'll take the dollar and they'll apply an algorithm to it, and they'll give me the euros back out. And so developers need to know how to do effective queries. Now, I may want to see where I've been spending my money. And so in this case, that's just reporting. Show me every time I've spent money in July. That's a report. Show me all the times I've gone to the home store and bought, some wood or plywood or whatever it happens to be. That's a report. That has not gone away. That is probably one of the biggest skills you need to have. The other thing I've always told everybody who asks me that whole computer question, when they say, what should my son learn or my daughter learn about technology? And I'm like, tell your daughter to go learn Excel.
Yeah.
And they always laugh. And if you because I did this with my daughter, if you put the word Excel, expert or certified or anything else in your LinkedIn profile, you will get hit on by a recruiter. Guaranteed. It is like a number one skill.
It's not
and
common.
when she got to work, my daughter got to work, there was the IT team that was there, and she became the go-to person for Excel. And they were like giving her raises because she was the person that could handle Excel formulas. So at any rate, reporting still super important. So there's sort of transactions, there's sort of queries, and then there's reporting. Those three things exist. They're valuable. They're never going away. And you need to know how to do them well. And if you're a developer that specializes in those first three levels of the ocean, you can retire on that. That is a place for you to go. Now, over time, I want to do some different kinds of queries. Let's go back to our bank and Jeffrey's ever burgeoning. I'm assuming you've got tons of money in Bitcoin or something, and you're
tons.
Fantastic.
Yeah, metric tons.
And you're fantastically wealthy, and you probably your biggest problem right now is managing all of your Ferraris and ocean yachts and stuff like that. So if that's your problem now, you've got larger sets of data that a standard SQL or NoSQL query find more difficult to answer a question. So for instance, I go to the bank and I say, how much money do I have? And they say, well, you've got $25. And all that. It's fantastic. Can I put more in? Yes. Can I take some out? Yes. Can I convert it into, euros? Yes. And then if I look at my teller and I were to say to them, is that good? Like $25, is that good? What would they say?
It depends.
I have no idea, dude. It's your money. I've told you. That's what, if you go to a database and say, is that good? Is that a good thing? Your database would go, do you want to put some money in or what? We got customers behind you, dude. Can you move on? Right.
Yeah.
So
I don't know the number for good.
Exactly. I don't know. What do you think? And I'm married, so that's really good. If I were to have $25 of my own, that'd be stunning. But my wife doesn't let me have money. So business intelligence is taking tons and tons of that data. And if I were to go to the bank and say, I want to know over time, do I spend more or less money around, holidays, and what kind of things do I spend it on? And do those things go down in price later? Could I have bought it at a different time during the year? That's the kind of question I want to know. And that would be business intelligence. And all business intelligence is pre-aggregated data. I take a structure, a snowflake schema, or some other schema that's more denormalized than we're used to working with. And I just simply parse that out and put it into a place. And then I run different kinds of queries over what we call dimensions. And these are just sort of slices of data that we're looking through. Like I just said, do I spend more money on, around the holidays? What do I spend it on? And could I have bought it at a different time later? So business intelligence is merely pre-aggregating data for complex queries from multiple dimensions. But the interesting thing about it is you have to know what those dimensions might be first, because if I'm going to put them into dimensions, I need to know what they are. Time is a number one dimension. Almost everything has a time dimension to it.
Yeah, month of the year.
Yeah. quarter and, all the breakdowns. Those are kind of built into most BI systems. They do that for you.
I can hear the developer coming out. Hey, what about the group by? You can just query and group and aggregate that. Why would I pre-aggregate it?
Absolutely. Whenever I see this, somebody says, "Oh, I need a BI system," I say, "Show me your queries, show me your reports, and then we'll take a look at this next." Do not add in something you don't need. If you can do it with a group by or a union or a left join or whatever it happens to be, then you should not be creating a BI system. However, sometimes the data gets so large and the dimensions get so unwieldy that the business intelligence system can take the time to generate those pre-aggregated queries to move faster for you. My definition of big data, by the way, is any data that you can't process in the time you want with the technology you have. Yeah. That's big data. So if you've got a Commodore 64, 1 megabyte of data is big data, right? There's no size. It just has to, how quick do you need it? And what do you got? What kind of hardware do you have that you can run it on? So business intelligence simply takes that place. And it also allows you to do some multi-dimensional queries, which are just not part of the Transact SQL language or not part of Gremlin or whatever it happens to be that you're using. So that still has a place. That business intelligence is absolutely a place. Business intelligence is exploratory in nature. It's not declarative in nature. You go in and you begin to ask questions. You don't just go to a BI system and there it is. You have to start asking it things, and then you can make there it is. Data science, on the other hand, deals with the idea of taking various features, which is just columns of data, like the red traffic light. Both red and traffic are dimensions, or rather attributes of the light that you happen to see. And light might even be a feature of traffic control, right? So you take those, but the difference is with the traffic light, or rather the data science portion of this, you're going to take an action because of that specific set of features and the algorithm that uses it. So you've got an algorithm in your head. If you just see a red light in a store as you drive by, you probably should not slam on the brakes. Mm-hmm. It's a different algorithm when it's in the store. In the store, if it's got a red light, you may say, "Oh, that's closed. I won't stop there." So you have a completely different algorithm. And that's the difference between business intelligence and the idea around data science. Because in data science, I'm going to take an action based on a certain algorithm, a particular algorithm, and a particular set of features. And what I'm trying to predict is called the target. I'm trying to predict what I want to do. And I take my features and I try to predict something called the label. And that's just, do I stop or don't I? And I can do that the same way that you learned to stop at a traffic signal to begin with. Somebody showed you tons of traffic lights from different angles, and they said to you, "That's a red traffic light, and you have to stop at it."
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Okay, so let me try to paraphrase, see how far off I am. Just the difference here with business intelligence. That's the area where I've decided I need to pre-aggregate data, and I can ask questions of it, but I still need to decide what questions I want to ask of it. But then that's where it stops. A human is on the hook for doing anything with the answer to those questions, and Perfect. Then data science is actually extending the program and having a program give the answer of the so what when it gets the answer to the question.
That is correct. And that's the number one part, Jeffrey, is what's the question? And so when somebody tells me they want artificial intelligence, here's the question I always ask: what are you going to do when you know the answer?
Mm-hmm.
That is the right. And if the answer is, well, I'll look up some more questions, that's business intelligence.
So then these practices are cumulative. You can't do business intelligence without the querying capability.
That's correct. Yeah.
You can't do data science without the
lots of data. Lots of data.
Yeah, lots of data and pre-aggregated data to work with. But then there's two more pieces. Maybe you can decipher them. There's the, hey, that's a red light, and that means that you should stop. And then who actually initiates the stopping?
Yeah. So let's peel that back a little bit. You actually don't need business intelligence to do data science. Those are complementary, but they're not sequential in any way. You would probably use the same base data, but in fact, you would not pre-aggregate it. Inside business intelligence, we do something called ETL: extract, transform, and load.
Which is really old practice.
That's very old. And we go all out to the data systems, to our different stores, and perhaps one store leads the product number with a 0 and the other store doesn't. So when we do our extract, we get the data. Our transform is to either add or subtract the 0 from one side or the other, depending on what we want to do. And then we load that into our final storage in this pre-aggregated way. In data science, it's the opposite. We don't touch that data. We bring it in as is, because I don't know which algorithm I'm going to use on it yet. And every algorithm needs a different level of transformation of that data. When you touch data in statistics, you changed it. And so it may not mean the same. So even just rounding up by one precision level or whatever, or converting the number 1 to the digit 1 has definite meanings inside statistics. And so you actually don't want to touch the data in AI. Now, to your other question, which was who decides to stop the car? AI can do one of two things. It can alert the human to take an action, or it can simply take it. So that's a self-driving car, right? The self-driving car says, red light, stop the car. But here's the thing. You've got to be extraordinarily careful with allowing AI to take that final step. And one of those, a simple example, is something called source data poisoning. Let's assume for a moment, I've just told you that what I do to the algorithm is I convert the red light, the picture of a red light, into digits. Obviously, computers can't see pictures. So I take the RGB values, I take the edge values, I take the size values, and I turn those into numbers. And then I train my algorithm and I say, every time you see numbers that look like this, that's a stoplight. And I run it through millions of examples. Just like when you learned to read in school, they taught you on tons and tons of books. And when you were all done, you don't need to bring those books anymore. You've got an algorithm in your head that says, this is how you read. Now you can pick up a book you've never seen and you can read it. Your model, your algorithm is now very small, but it can read. But it took a lot of books to get you there. We tend to forget that. So what if I were to take the source data and I trained the car to stop at a red light using pictures of red lights from different angles, different sun variables, nighttime, daytime, morning, afternoon, all those sorts of things. But what if, a bad actor, I was able to get to your source of graphics for the traffic lights, and I made them all green? And now your algorithm says, this is a red light. You only have to stop at these. And now I've shown it nothing but greens. And so when it comes up on an intersection, it's been trained. When you see this light, stop. Well, it doesn't see that because I've poisoned the source data, and it barrels right through the intersection. Right? So we have to be very careful about allowing AI blindly to take that last step. The Terminator premise is really true. You can't let machines decide, are people good? Because if I was a machine and I looked at the internet for 5 minutes, I always thought that the most realistic apocalyptic movie was the one, the Marvel movie with Ultron in it. He spent 4 minutes on the internet, decided to wipe out humanity. I think... So we have to be extraordinarily careful letting machines make that final call.
So it seems then that in layman's terms, if you say, hey, why is data science useful? then I might say, well, because it can use the data that's available to us to have the computer make recommendations to us. But
Yeah,
as opposed to, like, if it's a red light, it's not that this is a red light, therefore I can just automate the action because it's always a red light. It's, we kind of think it's a red light. So if I think it's a red light, hey, I recommend that you stop. Take that into consideration, and Buck, and decide if you'd like to stop.
No, that's absolutely, you've hit the nail on the head. And you hit two interesting points in there. One is that it should be an augmentation to human reasoning, I think. That's my view of AI, is that it should augment human reasoning. The second thing you mentioned there was
of AI?
Or the AI science should be, data science encompasses AI, ML, and deep learning, machine learning and deep learning.
Okay,
and in
so
fact,
it's the umbrella term.
It's the umbrella term. Data science is the discipline. AI is the product it can create. Okay. But you hit on another interesting thing there. You said, oh, I kind of think this might be a red light. That's exactly what it does. Whenever we query a database and we say how many ones are in this field, on this column, it'll come back and say there are 10 ones in the column. We don't expect it to say something like, I don't know, around 9. Yeah. We would be like, what? What is this, island time? No, how many are in there, right?
Right.
But AI does exactly that. We get a couple of things back whenever I ask for a prediction inside machine learning. This is actually called a score. And the score is, it's a red light, and I'm 80% sure. In fact, if you get 100% surety, in fact, in some cases, if you get above 90% surety, if it comes back and says, I am 90% sure that's a red light, more than likely you've done something called overfitting, where you've shown it too much data to train on, and it's just always giving you the answer that you want because it's already seen that answer. So, if all I have are apples in the room and you say to me, what's your favorite food? I'll always say apples because that's all I've got. Right. So that's called overfitting. So you should absolutely get a score back. You should absolutely train it multiple times, and you should retrain it. Like a human should have a little button there that goes, that was not a red light. And that should go back into the data set going, no, you were a little off there. And so on. Now, when we see modern cars, you've seen this, the lane drift thing where they're driving in the car, and when you go over the white line, it gives you the beep. Yep. It's just augmenting your decision process. Now, some of them, I think there's a car brand that will actually stop a car if you're about to hit something. So there's a little radar in front, and it's almost a switch. I mean, you could almost say it's a thermostat, right? We know what a thermostat is in our house. We do things like where we say, the temperature should be 72 degrees. And if it gets too hot, it'll turn on the air conditioner, but it's monitoring data all the time. The temperature is going by all the time. And when a certain value trips it, it performs an action. Is that artificial intelligence? It's just kind of a sensor. That is the way streaming works, if you put some other things on top of it. But the cars that are doing the stopping like that, that's more of a thermostat, because it's just looking and saying the radar says you're within 6 feet of something and you're going 60 miles an hour. That's a problem.
Yeah. But in those cases, am I right to say that the I would say engineers or the decision maker that said, let's automate the action, said that, you know what, in the cases where we get it wrong, we don't think that we'll be causing harm.
Right. That's exactly right. Yeah. You weigh the costs and benefits, and you say it would be smarter to stop the car even incorrectly when there's something literally stationary in front of it than to not. Now, because if I stop the car behind me could hit it. Yeah. Could hit me, right? Could happen. One would hope they all have the same kind of car, then everybody stops, right? But the idea is, well, I can tell you this: if you keep going, you're going to hit the back of a semi, and that's bad. That's hitting a truck is a bad thing. So I'm going to go ahead and err on the side of, getting hit from the back of your car is better than being slammed into the front of something. So that kind of thing. Yeah. So I think you're exactly right on that. And again, now, is that AI? I don't know, not really. Right. That's more of a sensor than it is AI. Now, there may be some AI in it. In fact, going back to our Excel example, by the way, I'll invite your listeners and you to look up later the concept called flash flash
Okay.
fill. I want you to play with that one time, and then I'll kind of spill the beans. That's actually an AI construct that does that work. So if anyone ever asks me about, can we get some AI in our company? I'm like, do you have Excel? And they're like, yeah. And I'm like, oh, you already have it. You're good.
So, and just quick search, there's a lot of stuff for flash fill, using flash fill in Excel. Is it specifically for that?
Yeah.
Okay.
Yeah.
Awesome.
Yeah. And you should play around with it. Don't just do one thing, play around with it a little bit and it will shock you. And I'll give you a sort of a forerun. Let's say I've got a column of first and last names. And on the right-hand column, I put, let's say I've got Buck Woody. I put an uppercase B and an uppercase W in the third column that has nothing in it. And then I say flash fill. It will automatically go enter the first and last letters, or rather the first letters of everybody's names in uppercase.
Oh, nice. I didn't know that.
And then change that to B.W. and make them lowercase and run flash fill again. And it will do the same thing. Put the first three letters, B-U-C, and do it, and it will go get the first three letters, and so on. It will infer what you want. It's not a formula. It literally goes and types it in for you. And it's using an engine that is guessing at what you're looking to do. And it's called flash fill. I use it all the time. And it is a stunningly cool feature and is useful feature. And that's
Nice.
AI.
Yeah, sounds like it. Sounds like it. Well, hey, man, this is jam-packed, good interview on data science. I appreciate you coming on and sharing us all those building blocks. As we kind of close out, we haven't talked about technology at all, and just to seed the listeners who want to jump off. I think there's been a lot of movement in business intelligence, and there's Power BI, and then there's Tableau, and everything. All those can work on top of SQL Server or whatever. But for those Visual Studio and .NET developers, what are the go-to tools that they should be kind of installing and learning if they want to extend their use of data to this predictive area?
Yeah, it's a few things. I'd recommend, just while we're here, if you just type in Microsoft space AI space school, Microsoft AI space school. If you do that, you'll come up. The first link should be the AI school from Microsoft. There is an absolute ton, a metric ton of classes for free online to teach you all about artificial intelligence and how you can do it. The primary languages you'll see used in AI are going to be Python is something to learn, the R language. And then if you're using something like, if you're using Spark or things like that, they have their own languages like Scala and others. You'll see TensorFlow, which is a library that's used in Python to do data science. But Python or R is really, and both are great. And it's okay to learn both, actually. But Python or R, if you're a developer, you'll probably gravitate a little bit more towards the Python world because it's more of an object programming language-ish. And then if you're a DBA or a data professional, R may make more sense. It's a little bit more of a functional language. Both can do very similar things, so you're not going to go wrong with either one. But those are the primary languages for AI. But if you try out this school, it's going to have everything you need. Really easy to get started. But there is math.
Of course,
there is math. Now, one thing I will mention as well as we close, there's something called cognitive services, Azure Cognitive Services. And if you go look those up, we've already built the AI for you. Image recognition, voice recognition, deriving sentiment from text, all kinds of AI built in that merely uses an API call. So you don't have to do any AI or ML to use AI and ML in your code. So I could send a picture of you right now to Cognitive Services, and it would say, male person sitting in a room with white curtains and age is about 45 or whatever it happens to be, or wearing glasses or wearing a blue shirt or a green shirt. It can do all those things and you don't have to write anything. It will just do that for you. Yeah.
Awesome. We'll include all that information in the show notes if you have any difficulty searching. And man, a lot of information. I learned a ton. Thank you, Buck.
Absolutely. Thank you for having me.
Oh, my pleasure. My pleasure. All right. Well, this has been a fantastic Azure DevOps podcast on data science with Buck Woody, and we thank you for coming on the show. And dear listener, until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.